Hello everyone. I hope that I'm audible to you. The screen is visible to you, students of JEE Kolhapur. Let me know in the chat box if the screen is visible to you and I'm audible to you. Okay. So hi everyone. I welcome you all in this session of motion in two dimension, or we can also say it motion in plane. We can also say it motion in plane. So this is the new chapter we are going to start today. As the attendance is very low, that's why I'm waiting for the students, but no one has joined. So we will starting the class. So in this chapter, firstly, we will introduce that what you have to learn. The first thing you have to learn about the vectors. What is vectors? Then, secondly, we will discuss about the addition and subtraction. Addition, or specifically, I'll say operations on vectors. On vectors, which include addition, adding of the vectors, subtraction of the vector, multiplication of the vector. Okay. So for today, we will confine our topic into these two topics only. We will confine this lecture into these two. Then further classes, we will analyze the projectile motion on the plane, then projectile motion on an inclined plane. So these are the topics of this. Okay. Now let's just start with the vectors. Now, what is vector? First of all, we should write the definition. What is vector? I know that you are very much aware about these vectors and all. That what's the point about studying it in a repeated manner. So it ultimately helps you in revision of yours. Okay. So vectors are the, and that is why I'm not going to dig down into this. I'm just writing the overall value that we are required. So vector is nothing but a physical quantity which has magnitude as well as direction. As well as direction. So कोई भी जो physical quantity हमारे पास है, if it is requiring the direction also to define it, then this will be categorized as the vectors. ठीक है. For example, the velocity, displacement, force, torque, etc. So these are the quantities that requires the magnitude as well as the direction to define. So these quantities are termed as the vectors. There is another quantities also which are termed as what? Scalars. So scalars are those which does not require any direction to define it, that have only magnitude. So physical quantity that only has magnitude is defined as scalar. For example, जैसे कि डिस्टेंस हो गया, मास, टेम्परेचर, etc. So whatever the physical quantity coming in your mind, that to define that you will never use any direction symbol, that quantity is the scalar quantity. Okay. Comment any two scalar quantity that you know apart from these three which is written here. Comment in the chat box. Now, if we try to find out about the more, if we dig down more in the vectors, so vector representation is the next topic. Vector representation. Now, we will define the vector with an arrow symbol. It's like this. An arrow. The length of this arrow is represent the magnitude of the quantity. Here, this is the length represents the magnitude of any quantity. More the length, more is the magnitude. And from tail to the head, it is the direction of it. Head is representing the direction of vector. So when vector is coming out of this plane, only the dot of the arrow we will see, the nip. So we will represent that quantity as dot. But when the arrow is going into the plane, so the tail we will see like this. Got it? That's why this is for out of the plane and this is for into the plane. Got it? So what I have told you, the length of any vector or arrow is given the magnitude, is provide the magnitude to us, and tail to head represents the direction of the vector. Where the head is pointing, that is the direction. Got it? Now, let's suppose the next topic is angle between two vectors. Now suppose let's say there are two vectors. One is this and another one is this. This is vector A, let's say, and this is vector B. So for any vector symbol wise, it is represented like this. We put the arrow over the symbol. If it is velocity, that it would be written like this. If it is acceleration, this force vector like this. Okay. So here we have taken two vector, vector A and vector B. A vector A does not represent acceleration. It's another vector. And let's say the angle between them is theta. Now, can we say that this angle is, we can take at the angle between two vectors? So for that, we have to check the first thing. To calculate angle between the vector, angle between vectors, either tail is combined, combined, or head is combined. Head is combined. Okay. So here in this example, if you will see, the tail of these two vectors are combined, lies at the same place. So angle measured between them, we can calculate it as the, and we can consider this theta as the angle between two vectors. But suppose this is vector A and this is vector B, like this. So can we say this as the angle of between vector theta? Can we say that theta is the angle between two vectors? No, we can't say that because here the head and head is not combined and neither the tail and tail. So for that we know, देखो, give me a moment. So as I was talking about the angle between two vectors, so we can say here these two vectors are not aligned as per the prescribed detail. Either the tail or tail should combine or the head or head is combined. So what we will do, as vectors are free in space, so we can move this vector in such a way we combine the head of it like this. Just a moment. So either we combine the head and head of it like this, or we can further move it in this direction. Got it? So now the tail and tail is combined. So this angle must be the angle between two vectors. Got it? As you can see, this angle, if I say it as theta 1 and this is theta 2, so theta 1 is greater than theta 2. So which angle need to be taken? The angle between two vectors, which has to be taken. So always take the minimum value of the angle, which means theta 2 we will consider as the angle between vectors. Got it? Now, for example, if two vectors are given like this, what is the angle between them? Consider this and this. So which one is greater? This one is greater. So we will consider this as the angle between vectors. Now, vector addition. और इससे पहले we will study resolution of vectors. Resolution of vectors. Now we know that if there is a vector given to us, vector A at an angle theta. So in the Cartesian plane, or we can say in the coordinate axis, if we represent it like this, we can break this vector into two components according to the axis. So this component along x-axis will be termed as ax, and the component along y-axis will be termed as ay. We can write that ax is nothing but a cos of theta, and ay is nothing but a sine theta. Now, there is a direct trick to remember this. Which one has to take as cos theta and which one has to take as sine theta. Always remember that from which axis the angle is measured, along that axis, the component of the vector will be always cos theta. For example, let's suppose this is an A vector and the angle is provided from this axis. So now the component along this vertical axis will be A cos theta and component of the opposite will be A sine theta. So this is the trick to remember it always. Now, again, one of the thing you can remember that how to find out how it has came as A cos theta. So this will become a triangle OAB. In this triangle, if you will see, OA is the hypotenuse, which is nothing but A. AX is the base. So if I apply the cos theta here, it will nothing but base upon hypotenuse. So from here we can say AX is equals to A cos of theta. Got it? Now, similarly, in the same triangle, if you apply the sine theta is nothing but the perpendicular upon hypotenuse. Now this perpendicular is parallel to this AY. So we can say that AY is equals to AY upon A is equals to A sine theta. So this is how we have derived these AX and AY. Similarly, in 3D, although we will not talk much about that in this chapter, but let's say if the questions came, then also you do not have any problem. Suppose this is a three-dimension plane, and a vector is also provided to you in the 3 dimension. This is vector A. Now, you can easily see how this vector is in 3D plane. Okay, like this. So in 3D plane, this vector has three component. Then we can represent the vector that AZ, AY, vector A can be represented as AX, I cap, AY, J cap, and AZ, K cap. Now, You're thinking about that. What is this AI, AY? Sorry, what is this I, J, and K? So we can say I, J, and K are the unit vectors. Unit vectors. Now, unit vectors are those which are having unit magnitude, and we are using these vector to represent the direction. So these are also termed as the direction vectors. So any vector can be represented in the combination of this. Got it? No. Vector resolution is done. Now, unit vector. This is the next topic. Unit vectors. A vector having unit magnitude. Unit magnitude. It is always given by, if we just put a cap on the symbol, this will represent the unit vector. Unit vector in the direction of vector A, and it have one magnitude. So if you calculate the magnitude of this vector will be 1. Got it? Now, how to convert any vector into a unit vector? So it's very simple. Suppose we have a vector P and we want to convert it into unit vector. So it will be given by P cap is equals to that particular vector just divided with the magnitude of it. So if we divide this vector with the magnitude, its magnitude will become 1. Got it? Now, in the Cartesian plane or in the coordinate axis that we will talk about, x, y, and z, this is y-axis, this is x-axis, and this is z-axis. So along x-axis, the unit vector is I cap. Along y-axis, the unit vector is j cap. And along z-axis, the unit vector is k cap. Okay. Now, let's just come back to the operations on vector. And here, with the next topic, which is multiplication of the vectors. Multiplication of vectors. So we usually have two types of vector product. The first is scalar product. And the second is vector product. Now it's very pretty simple to understand that the process or the product which gives a scalar quantity is the scalar product, and the product which gives a vector quantity is a vector product. Scalar product also termed as a dot product, and vector product is also termed as a cross product. Cross product. Now, firstly, we will talk about the scalar product, which is nothing but the dot product. Now, it is represented by A vector dot B vector, which gives you AB cos of theta. Got it? This is the mathematical representation of dot product. Now, suppose we are having a vector A in this direction, and this is vector B in this direction, and the angle between them is theta. So A vector dot B vector is nothing but AB cos of theta. Ultimately, what is the meaning of it? If you resolve the B vector in the direction of E, so this component of B vector is nothing but B cos of theta, as I have told you. So A dot B can be represented as A into component of B in the direction of A vector. Similarly, the same is also possible when you combine this A cos of theta, which means we can resolve A vector also. So if you drop the perpendicular, this is the component of it along B, which is nothing but A cos of theta. So we can also say that A vector dot B vector is equals to B into component of A in the direction of B vector. Okay. So this is it about the dot product. Now, what is the use of this dot product? The use of this dot product is to calculate the angle between the vectors. Now, angle between vectors. So we know that if A vector dot B vector is equals to AB cos of theta, we know that. So cos theta here is A vector dot B vector divided by magnitude of A into magnitude of B. This is also the magnitude of A and magnitude of B. I am directly writing is that. So this is how you can calculate the angle between two vectors. Got it? Now, how to do the dot product? For example, I'm taking, try to understand it. Let's say A vector is given as I cap plus 2j cap plus 3k cap. This is how we can represent the vector. And B vector is given as 2i cap plus 3j cap plus 4k cap. Now, how to calculate A dot? I cap plus 2j cap plus 3k cap dot product with a 2i cap plus 3j cap plus 4k cap. Now, firstly, this take up this I. This I will multiply to 2i and this I will also multiply to 3j cap and then 4k cap. Now, let's just focus on when I will multiply on 3j. So it will be 3 is a constant thing. So we can say it is a dot product with I and j, I dot j. Now dot product is also opened with this formula AB dot cos theta, AB into cos of theta. So it will also opened as magnitude of I, which is 1, magnitude of j, which is 1, the angle between them. Now I vector and j vector are the unit vector along x-axis and y-axis. The angle between them is 90 degrees. So it will become cos pi by 2 and cos pi by 2 is 0, which means the product of I dot j is always 0. The similar goes for I dot k, similar goes for j dot I and j dot k, and similar goes for the k dot I and k dot j. So from here we can say when I multiply with j or the opposite of it, the unit vector multiply the opposite of it unit vector, it will gives you 0. You can say I dot j is equals to j dot I is equals to k dot I is equals to I dot k is equals to k dot j is equals to j dot k will be equals to 0. So this is the first point. But when I will multiply I, j will multiply with j cap, k will multiply with k cap, it will give you 1. Because the angle between them is 0, cos 0 will be. So this is the two important note. you can take up here. Got it? Now, so in the dot product solution, you just need to multiply the same component according to the sign of them. So this will become I into 2I will become 2 here. 2j and 3j will be 2 into 3 will be 6 plus 3 into 4 will be 12. And this is a scalar product, so resultant will be a scalar quantity. So 2 plus 6 is 8 plus 12 will be 20 unit. This is the dot product. Got it? Now how to find the magnitude of any vector? So a vector का magnitude यहाँ पे कितना होगा? It is nothing but square root of whatever the component of I, 1 square, component of the j का square plus component of k का square, which is nothing but 3, or coefficient of k का square. So it will be 1 square 1 plus 4 plus 9, which is nothing but root 14. This is how we calculate magnitude of the vector. Got it? Now, let's just take up a question here to calculate the angle. A vector is given as, this is the question. Vector A is given as I cap plus 2j cap. Vector B is given as 2I cap plus j cap. Now find out the angle between them. So we can say that cos theta, which is nothing but the A vector dot B vector divided by magnitude of A, magnitude of B into cos theta. Magnitude of A, let's just calculate it early. This is I cap plus 2j cap dot product with 2I cap plus j cap divided by magnitude of I, A cap is nothing but square root 1 square plus 2 square, which is nothing but root 5, and similar goes for B. B will also root 5. So we can say root 5 into root 5, not cos theta here. And the dot product, same coefficient you have to multiply I with I, which is nothing but 2 plus 2. The root 5 will become 5. So 2 plus 2 is 4 by 5, which we can say 0.8. Now here cos theta is 0.8. So theta will be cos inverse 0.8. This is the angle between these two vectors. Got it? Now, the next topic here is cross product or vector product. Cross product. Cross product mathematically is defined by A vector cross B vector is equals to magnitude of A vector, magnitude of B vector into sine theta, angle between them, multiply with n cap. Now what is this n cap? Where n cap is equals to the unit vector. अब cap लगी है तो unit vector तो है, unit vector, but in which direction? Because cross product is a vector product, so the resultant of it will give your vector quantity. So along which this quantity is pointing out, we can say this is a C vector, which is equivalent to A vector cross B vector. Now, what is the direction of this C vector? The direction is given by this unit vector, which is nothing but unit vector perpendicular to the plane of A vector and B vector. Now, what does it mean? Suppose A vector and B vector are in the same plane. So, n cap will be perpendicular to these two. Perpendicular to this, perpendicular to this. This is the meaning of it. Now, Direction of cross product. Direction of cross product. We can say it is given by right hand thumb rule. Just place your finger to the first vector direction like that, as your palm is facing to the next vector. Curl your finger and whatever the direction of your thumb, this is the direction of this vector C. Now, there is another method to calculate this C. Let's say C vector is equals to A vector cross B vector. If vector A का magnitude is given as A1 I cap plus A2 J cap plus A3 K cap, and B vector का magnitude is given by B1 I cap, B2 J cap plus B3 K cap. Now, C vector is given by the determinant of A vector and B vector, which will be given by the first row will be I, J, and K. Second row will be the coefficient of first vector, as of sign A1, A2, A3. B vector is B1, B2, B3. Now, just open this determinant and you will be having a resultant vector as C. So this is how also we can calculate the cross product. Got it? I hope till now you don't have any kind of doubt or any issue. If you have, you can ask right now because the lecture is being over right now. So any kind of doubt will be entertained. You can ask it. Okay, then take care of yourself. Bye bye.